All right, we are live, and we are on 3.6. Can everybody go to 3.6 in their notes? This is usually, for most people, the toughest of the factorings. Okay, I'm actually going to just do something on scraps. I'll just do it off to the side. You don't even have to write it down if you don't want to. I just want to point something out that I don't know if anybody noticed this while they were foiling. Let's do a couple of foilings. Specifically, let's do foilings where we have coefficients on the first term of the bracket. So let's say I was going to FOIL 2x plus 3 times 3x minus 4. So let's FOIL that. First times first is 6x squared. Outside times outside is minus 8x. Inside times inside is plus 6x. 6. Apparently 3 times 3 is 6. Sorry. Yee. And then 3 times negative 4 is negative 12. Obviously, what's the next step? The next step is to collect like terms, right? I did say you didn't have to write this down. I just need you to watch this one. This isn't the real notes yet. This is our warm-up. All right? Now, there's probably people going, I am so good at foiling. Those of you, remember when I first showed you this back at the beginning of the unit, there were some people who said, yeah, we did this a little bit in grade 9. Some grade 9 teachers get the foiling. So there might be some people who just go, and you just skip that middle step, right? Or you can kind of juggle the middle step in your head. You can just kind of go 2 4s is 8, but it's a negative. 3 3s is 9. 9 minus 8, and boom, you get the 1. Okay, so if you're one of those people who's been skipping the middle step, can I ask you to just consider the middle step? Let's do one more. Let's do one with maybe slightly bigger numbers. How about 3x minus 5 and 4x plus 7? There we go, bigger numbers. So can you maybe just take a piece of scrap paper and just jot down those 2 steps for this one, okay? I'll give you a second to do that. And I'm going to keep an eye on the chat. So guys at home, if you have any questions, you can ask away. All right, was that enough time to give you get this next line down? Did you get 12? Come on, pen. 12x squared plus 21x minus 20x minus 35. And that ends up being 12x squared plus x minus 35. Now, I got to tell you, the fact that they both had a plus x in the middle is a sheer coincidence because I made these up in my head and I wasn't trying to do that. But there's something else about this that I want you to notice that is actually kind of hard to notice until somebody points it out to you. And it's about this middle step here. And what I want you to notice about the middle step is something that, again, I don't know if you noticed this or not when you were foiling, but it's very cool. See this digit here and this digit here? Multiply them together. What's 6 times 12? Actually, keep the negative on the 12 too. What's 6 times negative 12? Negative 72 is correct. 6 times negative 12 is negative 72. Now check this out. What's negative 8 times positive 9? Yeah, and will that always be true? And the answer is yes. That will always be true. Even when the numbers get bigger. Like, oh boy, 12 times 35. Quick, what's 12 times 35? Oh, come on, that's not that hard. 30, what's 3 12s? 36. So what would 30 12s be? Slap a 0 on it. 360, and then 5 more 12s. What's 5 12s? So 360 plus 60? So we are looking at 12 times negative 35 is negative 420. Is that true of what those two numbers are as well? Yeah. 21 times negative 20 is negative 420. That little property, that this number times this number is always going to be equal to this number times this number is something that until now you probably never noticed. But now that we do know that that's a fact, we get to use it to help us factor things that are hard to factor. Specifically, we're going to do what's called factoring by decomposition. So first of all, I'm going to basically define factoring by decomposition. To factor using the decomposition method, I'll try to keep to printing. I know some of you don't read handwriting very good. To factor using the decomposition method, you decompose the B value into two numbers with the sum B and the product AC. Oh, and I just realized that there's a typo in the notes. There's supposed to be an A in front of that x squared. Can you put an A there? Obviously, if A is 1, then I don't have to factor this way. So to factor using the decomposition method, you decompose. What does the word decompose mean in, say, science? It means to break down, right? When something dies and rots, it decomposes into its mineral and cellular components so that it, ends up back in the soil or whatever. So that's the idea. We're going to break down the B number. So in other words, just to write this out in symbol form, come on, pen. Given ax squared plus bx plus c, where a is not 1. If a is 1, I'm just going to go back to the way we factored them last class, right? Just open up two brackets and say what two things times to make c and add to make b. But what happens when there's an a value there and it's not 1? Well, we do have some. We had some in yesterday's homework where a wasn't 1, but it was able to factor out, right? It was a common factor. So I should say where a is not equal to 1 and a is not a factor of B and C. I should probably have said both B and C, because sometimes it's a factor of one of them but not the other. You know what? I'm going to add the word both now that I think about it. Both B and C. So given that, I am going to take ax squared plus bx plus c, and I'm going to decompose it into ax squared plus, I'll use two new letters. I'll use n and m. nx plus mx plus c. And I know that n plus m is what b equals. So I decomposed the b number into two numbers called n and m. And I also know that n times m is equal to a times c. So there, in very symbolic language, is what we're going to do. Now that looks maybe complicated for people who aren't great at reading math symbols and translating it to basic everyday English. You got to get used to that, though. Math is about symbols. And it always has been, right? I'm a professional math teacher. It's what I do for a living. You know how often I get those people, you meet them at social engagement stuff. Oh, I sucked at math. I'm bad at math. It's like, yeah, great. Don't admit that to your kids. Makes my life hard. Lie to them. Tell them you love math. Tell them math was the coolest subject ever, and you were great at it. Do you admit your other shortcomings in life to your children? No. So why do you brag about being bad at math? And then they usually follow that up with, I used to be good at it. I was good at it in elementary, and then as soon as algebra came along, that's when it got hard. And I say, why do you think that is? And they go, well, usually the answer is, they'll say, well, because I'm not good with symbols. I'll say, really? Like, what's this? Isn't that a symbol? It means this many. I just held up my hand, people at home. So, I mean, that's a symbol. All math symbols, even arithmetic is symbols, right? That's a symbol. It means multiply. That's a symbol. It means add. It's all symbols. So I don't know where those people, I think they just got to the certain age where they stopped trying. That's what I think. They don't like to admit that. It's like, it got hard. No, you got lazy. That's what happened. Okay, example 1. All right, so first of all, is this the kind where I want to decompose? Is A equal to 1? No, it's 2. Is the 2 a factor of the B and C numbers? No, 7 and 5 have no 2's in them. So I am going to try this new decompose method. So here's how it works. I am going to decompose, that's an E, decompose 7 into a sum. That's sum, right? That means 2 numbers added together. Where those 2 values have a product of 10. Where am I getting the 10 from? Because that's what 2 times 5 is. So in other words, 2 times 5 is 10. Come up with 2 numbers that times to make 10 that add up to make 7. Well, in this case, that's not very hard. It is 2 and 5. Oh, isn't that nice? So it's 2 and 5. So I'm going to now decompose this into 2x squared plus 2x plus 5x plus 5. There. See this part here? This used to be 7x. It's decomposed now. Now, what was the point of doing that? Well, I'm now going to do the part, the step that we call partial factoring. And partial factoring means that maybe I can't factor something out of all of the terms, but I can factor it out of some of them. Like, for example, notice that both of these 2 terms have a common factor of 2x. So I'm going to take that out. I'm going to take 2x out of the first 2 terms. And hey, notice that the next 2 terms have a common factor of 5. So I'm going to take out a 5. What's left behind? It's like I have a yellow left behind here. Come on. There we go. And a blue left behind. What goes in those 2 spots? If you factor 2x out of the blue things, what do you got left behind? You've got x plus 1. And isn't this cool? What happens to the 5x plus 5 when you take out a 5? You get x plus 1. And will the bracket always be the same when you do this partial factoring? If it's factorable, yes. If the brackets aren't turning out the same, either A, you've picked the wrong numbers and done something wrong, or B, maybe it's possible we threw one at you that doesn't factor at all. Was there any in last night's homework and the night before's homework that didn't factor at all? Like, for example, let me just move over for a second. Again, you don't have to write this down. Did we give you one like this? Quick, what 2 numbers times to make 5 and add to make 3? There aren't any, right? So that doesn't factor, right? I bet the homework, all of them factored, right? So we didn't throw any curves at you like that. I'll bet that happened to you in grade 5 too, right? I bet in grade 5 the teacher said, hey, okay, make a factor tree for this number. And then you sat there and went, but Can't I use 1 and 29? No, you're not allowed to use 1 in a factor tree because 1's not prime. So you just have to look at it and go, well, I can't make a tree. It's done. Same idea here. I can't factor that. It's done. In fact, you know what you can call it? It's a prime trinomial. Okay? So sometimes there are prime trinomials. If I tried my very darndest to decompose 7 into two numbers that multiply to make 10 but add to make 7, and I couldn't find any, then it's prime. But if I do find a pair, and then when I do partial factoring, this happens, here is the final answer. And if you don't believe me, remember, you can always check. How can you always check that you did it right? You can expand it, right? FOIL it out. X times 2x is 2x squared. X times 5 is 5x. Plus 2x is 7x. And 1 times 5 is 5. So, yep, it would FOIL out to 2x squared plus 7x plus 5. So it works. Now, there's people who always look at this step here and go, how did you get from there to there? Can I maybe make a little note? Suppose I had 2xz plus 5z. How would you factor that? What's always the first thing you look for when you're factoring? A common factor. Wouldn't you just factor out the z and say that it's 2x plus 5? Great. That's what I did over here. It's just that my z happens to be a binomial, x plus 1. So I factored out the x plus 1. If that's hard for you to get your head around, you can kind of just memorize it as a pattern. Notice that this bracket stays the same. And guess where this bracket came from? It's the leftovers that were in front of the bracket. All right, let's try another one without all the words and highlighters. 5x squared plus 11x plus 2. Okay, so let's run through the process again. Step 1, always look for a common factor first. Does 5 go into 11 or 2? No. So let's decompose. 5 times 2 is 10. Give me two numbers that times to make 10 that add to make 11. 10 and 1. I'm going to decompose this into 5x squared plus 10x plus 1x plus 2. Sometimes people don't call this decomposing. They call it anti-foiling. Because notice this is actually just foiling backwards. Right? When you FOIL, you get 4 things. And then the 2 things in the middle end up being like terms. Well, I just went backwards. I started out with this being one thing, and I split it into 2 like terms. Now I'm going to do the partial factor. I'm going to take out 5x, leaving behind x plus 2. And, ooh, I can't take anything out of x plus 2. So you know what I'm going to factor out? I'm going to factor out the number I can factor out of every number. I'm going to factor out a 1. And then can you see what the final answer is going to be from there? Look at the way you did the one just above it. What's the last step here? The x plus 2 factors out, leaving behind the 5x and the 1. Now, often when I teach this stuff, I get people who at this point go, well, wait. I didn't really need this fancy decomposition. I was able to just sort of tell, look, 2 and 5, look, I can just go, here, let me copy the question out. Let me get rid of that. No. So what was the question again? It was 2x squared plus 7x plus 5. So if I go 2x squared plus 7x plus 5, I can just sort of tell that the only way I'm going to get 2x squared is to go 2x times x, and then 5 is a prime number. How many different ways can you multiply to get 5? Oh, and I know they both have to be plus, right? Because otherwise you wouldn't get a plus here and a plus there, right? Logically. So what's with this rigmarole? It's either 1 here and 5 there, or vice versa. It's only 2 choices. Do I really have to go through all those steps when there's 2 choices? Let's try putting the 1 here. Oh, doesn't work. I'll put the 5 here. Done. All right, now you see what the problem with that particular method there is what happens when these numbers start to get bigger and have lots more factors. 2 and 5 are prime. What happens when this number here is a 6 or a 12? Think about how many different factors there are for 12. 1 and 12, 2 and 6, 3 and 4. What if it was 36 here at the end? 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. You could be sitting there guessing and checking what these things could be for a very long time. See the problem? That's what makes decomposition actually quite efficient if you know what you're doing. It doesn't take as long to guess and check what the factors are. So, looking at the third one here, well, 3's prime, so I kind of know it had to be 3x and x if I wanted to just do it by kind of guessing and checking again. But 10, again, breaks down. First of all, 10 could be 1 and 10 or 2 and 5. And that negative complicates life, because it could be -1 and +10 or +1 and -10. -2 and -2 and +5, -5 and +2. Too many choices. I don't want to sit there and try 6 things before I hit the right answer. So, what's 3 times -10? -30. What two numbers times to make -30 but add to make -10? Careful, it's not 3 and 10. It's not 5 and 6 either. There they are. For people going, wait a minute, isn't it 10 and 3? 10 and 3 makes 13. Yeah, but remember, if you multiply to make a negative, don't they have to be opposites? There's no way +10 and -3 would add to make 13, right? They'd subtract each other. Does everybody get the logic on that? So yeah, it had to be 2 and 15. That's my pair. So let's put that pair in here. Instead of -13x, I put -15x and +2x. And again, that's where it gets its name from. I just decomposed this number into those two numbers. Somebody at home still wants to do it the guess and check way just by going, and they said, just get good at it. Is that what you meant by that comment? Just get good? Okay. Sure. Start juggling numbers that have like 12 sets of factors and see how long it takes you to factor something. I don't think so. No, the decomposition method's actually, it's a little complicated to learn, but once you master it, it really does allow you to factor a lot of things easily. In fact, I've often had students who, once you show them this method, they don't want to guess and check anymore. They get easy ones like, like the ones that were in your homework last night, like x squared plus 6x plus 9. And they start decomposing the 6x. And it's like, well, wait a minute, this is a 1. You know that it's just this and this. And then you just have to ask yourself, what two numbers times by 9 and add to make 6? And they go, yeah, but that's more thinking than doing it the other way. So they have a point. I guess I wouldn't stop you from using decomposition on any of the ones you want. But the idea is when there's a 1 in front here, you're just kind of guessing and checking. That's the idea. This one, however, I'm going to now partially factor. So what partially factors 3x squared and 15x? What can you take out of 3x squared and 15x? You can take out 3x. Come on, you. Leaving behind x minus 5. What can I take out of 2x minus 10? And once again, I've got that same bracket. So the bracket factors out and leaves behind that. All right. Somebody's got their hand up. All right. How do I find that person? I don't know how to find you, person with your hand up. Just ask your question. What do you got?
Minus 10 times 3 is equal to minus 3.
Yeah.
So, why can't we use that?
We did use that. 10 times 3 is minus 30. That's where I got the 2 and the 15 from. I needed two other numbers that multiplied to make minus 30.
I don't understand.
Well, let's try another one. See if that helps. Actually, number 4 works a little differently. Examples 5 and 6 are going to work the same as this one. So we'll get back to that in a minute. So example 4 first. What can we do with this one? Careful, what do you always look for first? Yeah, what's the common factor here? Notice they all have a 2. So I would factor out a 2, leaving me x squared minus 5x plus 6. And then this is easy. We call this factoring by inspection. I just inspect it. and go, oh yeah, what two numbers times to make 6 but add to make negative 5? If two numbers times to make a positive, they're either both positive or both negative. Could I possibly add two positives and get a negative? No, so I know they're negatives. And then what do you do to 6? What two numbers times to make 6 but add to make 5? 2 and 3. Okay, so that one has a common factor. Actually, I think all the rest of them do. Yeah, all of the rest of them do. Okay, so I don't know that I'm going to need to decompose this one either. Let's try it. Let's factor out, you know what I'm going to factor out to make my life easier in this one? I'm going to factor out a negative 3, leaving behind 1x squared plus 3x minus 4. And now that there's a 1 here, I can just factor this by inspection again. Quick, what two numbers times to make negative 4? Well, if they times to make a negative, they are definitely opposites. And 4 could be 4 and 1, because 4 minus 1 is 3. So it's going to be plus 4 and minus 1. So I didn't need to decompose that one either. That's 2 examples in a row. Let's take a look at this one. Once again, I do have a common factor. I can take out a 3. But that still leaves me with 6k squared minus k minus 2. So now, if you wanted to do this, don't bother writing this down. But if you wanted to do this the way that we just did the last couple, notice that you'd be going, well, maybe it's 6 and 1. Maybe it's 3 and 2. Maybe it's 2 and 3. You're going to be juggling lots of factors, wondering which one is the right fit. The decomposition method makes life a little simpler if you can get your head around how it works. So we're going to decompose negative 1 into 2 numbers. What do I know about those 2 numbers? They have the same product as 6 and negative 2. So what 2 numbers am I looking for? Let me get rid of all this stuff. Okay, so 6 times negative 2 is negative 12. So what 2 numbers would add to make negative 1, but multiply to make negative 12? No, that would add up to make negative 11, or positive 11. They have to be 1 apart. Because remember, one of them has to be a plus, one has to be a minus. What 2 numbers times to make 12 and they're only 1 apart? 3 and 4, right. But I need a negative 1, so it's negative 4 and positive 3. So check this out. So this is going to be plus 3k minus 4k. So a person who asked the question a minute ago, do you see where I got these 2 numbers from? I had other choices for negative 12, right? Negative 12 could be negative 1 times positive 12. But that wouldn't add up to be negative 1. So that's the pair I needed. Now I do the partially factoring thing. I'm going to use brackets inside of brackets. I'm going to switch to a square bracket here. I'm going to factor out 3k from the first 2 terms. And I'm going to factor out negative 2 from the next 2 terms. And looky there, brackets are the same. So I can factor that bracket out of the 2 terms that I have there. And actually, I don't really need the square bracket anymore. There's my fully factored statement. Now, let me show you something kind of cool. Once I've found these 2 numbers, notice it actually doesn't matter what order I put them down. If at this step here, what if I'd have put the minus 4k in there first? Would it have mattered? I mean, it looks different. And it factors different, right? Right here, I was able to take 3k out of those 2 things. I can't take 3k out of these 2 things. I can take out 2k. So actually, you know what? I needed the square bracket again. I can take out 2k, leaving behind 3k minus 2. And factor a 1 out of here. And I have 3k minus 2. And look at that. I'm actually going to get the same exact answer. I hope everybody understands that that is the same answer, right? Think of it as a number times a number times a number. You can times 3 numbers in any order you want. So the order of the factors doesn't matter. And the order that I put these two decomposed things in doesn't matter either. Feel free to go back to the other examples where we decomposed and switch the order of those two numbers that you decomposed to in the middle. You'll still get the same answer. Just the factors will be in the opposite order. So that's factoring by decomposition, and like everything in math, it takes practice. So what I've picked for homework is, let's see, blog. Okay, oh, that's not the blog, that's the textbook. That's the blog. So what I picked was not that many, just 13, 14, 15, and 19 on page 177. Yeah, there's A, B, and C parts, but it's still actually not that much work. Okay, but they take practice. You have to actually try this for yourself to get good at it. So give those a try. People at home, you could get started on it right away. People in class, we're going to do a little activity just to solidify the last factoring by inspection. The other half of the class did it yesterday. So here we go. I'm going to stop my video now.